We're still in the transformation section, and right now we're going to look at reflections. So if we have a negative outside, it'll be a Y movement, or if we had it inside, it would be an X movement, and it's going to make the graph flip. It's going to reflect across the axes. So if we have the negative on the outside, then it's a Y movement, and it's reflected about the x-axis. The points, when you reflect it, xy becomes x negative y, and we'll check that after we do one. The sign on the y value changes. Since the negative is in front of the f of x, it's a y thing. And that's why the sign changes on the y value. So we're going to use the graph of f of x equals cube root of x. So it's one of our standard graphs, and we want to obtain g of x, which the only difference is it has a negative on the outside. What that's going to do is it's going to reflect this picture, and I'm going to try to draw it so it looks the same. So, like that. And this one is going to flip up like that. And so let's check one of the points. If we have this point, it is 1, 1. And we said that the y becomes negative. So this is the point that flipped. It is 1, negative 1. So we had 1, 1. It becomes 1, negative 1. And you can see it's the y value that changed signs. Let's check over here. So let's check this one. And I'm just picking these because they land at integers. Right? And so this is negative 1, negative 1. And we flipped it up, and now it's here. And so it is negative 1, positive 1. And it is the y value that changed signs. So this is a reflection about, it's the x-axis that they flip over. It's a y movement, but it flips over the x-axis. We have another example to do. It says use the graph of f of x, this is f of x, to sketch g of x, which just has a negative on the outside of f of x. So it's going to flip over the x-axis or reflect over it. The ones on the axis will stay there. So this point is going to stay. This point is going to go down. This point will stay. This point will go up, and this point will stay. So now we can connect. And that is our new picture. There is another thing that you could do if you had a more complicated thing with other pieces on it. You could work from the table and multiply your y's by negative 1. So let's put our original table. So we had negative 2, 0. We had 0, 4. We had 2, 0. We had 4, negative 2. And we had 6, 0. And so having a negative outside, this is like a negative 1. And it's a y movement, so it is negative 1 times your y's. So our new graph, the table for it, the x's are going to stay the same. The y's are all going to multiply by -1. -1 times 0 is still 0. And 1 times 4 is -4. 0. Two negatives will give you positive and 0. So let's just double check. Those are the points on our new graph. Notice your y's here did change to the opposite. X's stayed the same and the 0 is not going to change. So let's just check a couple of them. 6, 0, that should be on the red one. 6, 0, we're good. 4, 2, 4, 2. 2, 0 is here. 0, -4 right here. And -2, 0 right there. So there is more than one way to do it. With only the one thing, the reflection, it's easy enough to just flip it. The graph of y equals f of -x is the graph of y equals f of x reflected about the y-axis. Notice that your negative is on the inside with the variable. So this is an x movement, so it is going to flip across the y-axis, but it's going horizontally. When you reflect a function about the y-axis, your xy becomes -xy. The sign on the x value changes. Since the negative is inside, it is an x thing. That's why the sign changes on the x value. So we're going to use the graph of f of x equals the square root of x to obtain the graph g of x equals the square root of -x. And this will be a reflection around the y-axis, and because the negative is on the inside. So this will be y, right? And so we'll do points. This one should be, and for something like that. So that is just flipping it across. Let's check just a couple of our points. So we have the point 1, 1. And when we flip across, it becomes -1, 1. I'll have to write it down here. And notice it is the x that changes. Right? The x changes to its opposite and the y stays the same. These others are not whole numbers, so I'll just leave them. But you can see it in that one example. All right, and we're going to use the graph of f of x, which we're given, to sketch the graph g of x, which is f of -x. So the negative is on the inside, so it's going to flip horizontally across the y-axis. So this point is going to flip to right here. This point will stay the same. This point will flip to the other side. This point will flip to the other side. And this point will flip to the other side. This is the one that stayed the same. And so this is our graph flipped across. This one point came over to this side, and the rest of it all went to the other side. We will also do it from the table, just like we did on the other one. So we'll make our original table. Right, our original table, we had -2, 0. We had 0, -3. We had 3, 0. We had 5, 2. And we had 7, 0. Right, and in here you're supposed to do the opposite. But if you multiply by -1 or if you divide by -1, it is actually the same. It gives you the same result. So we can just say multiply by -1, but if we're doing the reverse, we would divide by -1. We'll just do that. We'll divide by -1. Right, so it's the x's that are going to change. The y's are going to stay the same. This will be -2 divided by -1 will be +2. This will still be 0. 3 divided by -1 will be -3. 5 divided by -1 will be -5. And 7 divided by -1 will be -7. So let's check. These should be our new graph, right? So 2, 0, that one is on here. 0, -3 is on here. -3, 0 is on here. -5, 2, and -7, 0. So you could do it by the table, or with only one thing to do, you could flip it. Next, we're going to look at vertically stretching and shrinking graphs. Remember, if it's going to be a vertical movement, it's a y movement. It's going to be on the outside of your function. So it says let f be a function and c be a positive real number. So this would be our c. If c is greater than 1, then the graph of y equals c times f of x is the graph of y equals f of x vertically stretched by multiplying each of its y coordinates by c, whatever this number is outside. If c is between 0 and 1, so it's a fraction, then the new graph is going to shrink by multiplying each of its y coordinates by c. So this is our original graph. I always do this kind of movement from the table, or this kind of transformation from the table. So I went ahead and took all the points and put them in the table. You would have to do that. And so it is outside. That means it's doing something to the y. And when it's doing something to the y, you go ahead and do exactly what's there. So I'm going to multiply all my y's by 2. Right, the x's will stay the same, so I can put them -2, -1, 0, 2, 3, 4. All right, so I have 2 times -2, which will give me -4. 2 times 0 is 0. 2 times 3 is 6. 2 times 0 is 0. 2 times -1 is -2. 2 times 0 is 0. We'll make our new graph. So -2, -4, -1, 0, 0, 6, 2, 0, 3, -2, 4, 0. So this is our new graph. It's supposed to look the same. It should be curved there like the original, which it would be if it just wasn't the drawing. Now, what I'm going to match up is the height of each one. So my first one, I have 2 units below and 3 units above. So the height of the first one is 5 I'm just going to abbreviate, height is 5 units. And the second one, we're going to count the height from here to here. All right, and so that is 1, 2, 3, 4 units below, and 1, 2, 3, 4, 5, 6 units above. So 6 plus 4 is 10. Notice this is 2 times the height of the original. So it stretched it vertically by a factor of 2. We have the same graph here for our original, and we're going to multiply it by a half. Notice the half is on the outside. That is a y movement. So we're going to multiply each of our y's on the table by a half. The x's will stay the same. So negative 2 times a half will be negative 1. And you can write your fractions or do them on your calculator. 0 times a half is 0. 3 times a half is going to give us 3 halves, or 1 1/2. 0 times a half will be 0. Negative 1 times a half will be negative 1/2. And 0 times a half will be 0. Nice to have those zeros there working with fractions. All right, so negative 2, negative 1. Negative 1, 0. 0, 3 halves, which will be 1 1/2. So don't go over, but go up 1 1/2. 2, 0. 3, negative 1/2. And 4, 0. Right, and we can check our height on these. The original one is 2 plus 3 is 5. And our new one is 1 below and 1 1/2 above. So that will be 2 1/2, which is half of the 5. And it's between 0 and 1, so it's going to shrink it by a factor of 1/2. We have one more graph that we're going to look at, and this one we're going to do 2 transformations to the graph. We are going to do a vertical stretch because it's on the outside. We're also going to do a vertical shift because this one is added on the outside. So what we will do first is write down our original table. So our original table, we have negative 2, 0. We have 0, 2. We have 2, 0. We have 5, negative 1. And we have 6, 0. Right, and your order, you're supposed to do first any horizontal translations or horizontal shifts. Then you're going to do your stretches and reflections. And the last thing is a vertical shift. So with the 2 that I have, I'm going to do my stretch first. So I'm going to do 2 times my y coordinates, and my x will stay the same. So this is table number 1, my original. Table number 2, my x's stay the same. Right, and my y's are going to multiply by 2. So 2 times 0 is 0. 2 times 2 is 4. 2 times 0 is 0. 2 times negative 1 is negative 2. And 2 times 0 is 0. Now, I'm not going to put it on the graph until the end. So my third table will be to add 1. And this is outside the x, so it's going to add to the y's. So my x's will stay the same as my second table. And my y's, I'm going to add 1. All right, so I have 0 plus 1 is 1. 4 plus 1 is 5. 0 plus 1 is 1. Negative 2 plus 1 is negative 1. And 0 plus 1 is 1. All right, now I will put my new graph on there. So I have negative 2, 1. 0, 5. 2, 1, 5, negative 1, and 6, 1. All right, and we can just check it a little bit. Let's check it about the stretch for one thing. And so it was 2 units high here plus 1 more. So the original was 3 units. And the new one, we're 1 below. And we are 1, 2, 3, 4, 5. So our new, the height is 6. All right, so that is the times 2. And it's shifted up 1. So you, on this point that would not move with multiplying by 2, you can see the shift. And you can see the shift here at 0. And you can see the shift here at 0. The others encompass the multiplying by 2. So 2 times this 2 would be 4. And then shifting 1. So you can kind of look back at that. But I would do these strictly from the table. Just be careful as you write them. It's not that hard.